continents, of course, they are less dense. The continental plates are less dense than the oceanic plates, uh, and you know, where there are mountains, they dip well into the asthenosphere, the upper part of the mantle. Um, they tend to move much slower than the ocean plates. All right, so that's important to think about. The ocean plates move much faster. All right, so continental plates tend to move slower than the ocean plates because, well, I just kind of gave it away. Their roots extend deep into the mantle, right? They're certainly not heavier. They can be convergent. That's true, but that's not why they're moving slower. And certainly not because of gravity. All right, so it's A is the right answer. All right, so interactions between plates can occur along, you know, plate boundaries. You're going to get here. Let's see. Do they show the pictures? Here, let me show you the picture that I'm talking about. Here, let's do that. This is in your textbook, of course. Oops, right here. All right, so you can see it over here on the right hand side. So when the two plates move apart, that's called a divert. Those are divergent plates. If the two plates crash into each other, those are called converging. So diverging, the top one, diverging, they're moving apart. Converging, they're moving together. And then if they move past each other, if they kind of slip past each other, that's called a transform boundary. All right, so this one's transform, converging, diverging. All right, so that's important that you get those pictures in your head. Just to let you know, not all of them, they don't all have to do this, but most of the diverging ones are in the oceans. They don't have to be in the oceans. There are some that are not in the oceans, but most of them that you find are like that. All right, let's go back to our slides. All right, so here from current slide, there we go. So interactions between the plates occur in the boundaries. That's kind of you know, those are the type of boundaries that I just went over. The creation and destruction of the lithosphere can occur at these boundaries. And of course, you get earthquakes, you get volcanic activity, you can get mountain building as well. And remember, it's always with the plate boundaries that we're talking about. Okay, so here we go back to what the boundary there are, the different. It's color coded here where the boundaries are. All right. Okay, so it's good to look at that map occasionally. All right, so the divergent boundaries are when they're moving apart from each other. Magma wells up from the mantle, and generates new lithosphere. Right, new land, or well, it's not land, new crust, right? Because the magma will solidify, and again, this happens mostly in the middle of the oceans. All right, so and then convergent plate boundaries, the magma, you get magma generation, and what happens here is usually what happens is one plate will slip below another. But by the way, a term that's usually talked about for divergent boundaries is called rifting. There's these rifts, like for example the Mid-Atlantic Rift, and then converging is if one slips below the other, that's called subduction. All right, so we'll get more into that in just a moment. And then, of course, these transform faults. Notice with these two, the diverging and the converging, you get magma that is coming up from the mantle, and the difference between these two, of course, is that this one's creating new lithosphere. This one is destroying lithosphere because there's subduction going on. And then with the transform fault, for example, the most famous one of them all is the San Andreas fault. We'll get more into that later. So you don't get any magma generation. You don't get any formation or destruction of lithosphere. But there are lots and lots of earthquakes that can come from this kind of a fault. All right, so we'll look at these a little bit in a little bit more depth. The plates that are moving away from each other, of course, this is a divergent. And see what's happening in the upper part of the mantle, the asthenosphere. So sometimes I have trouble saying that. The asthenosphere. It is, when the plates move away from each other, this material can go between, where the plates once were, and that magma will solidify. Just think about it as at the bottom of the oceans, or it doesn't have to be at the bottom of the oceans, but that magma rises up to the surface. Yeah. When you think about surface, you're thinking about I think about the surface of the Earth. But either way, if it's the bottom of the ocean or the land, the magma will cool and solidify, right, and forms new rocks. All right, so as I said, most of this happens with the mid-Atlantic ridge. There are actually what are called rift valleys. There's a very famous one that I was kind of talking about that in a previous video. In Africa, there's a giant rift valley in Eastern Africa, right? It's very far into and that's in fact someday perhaps that rift valley will split apart so much that there'll be a new ocean, and one side will be the original African plate, and the other side will be the Somalian plate. All right, because that's where that rifting is taking place. All right, so this does have there are earthquakes that are associated with this, but not super strong earthquakes. Okay, so there could be even moderate earthquakes that are associated with divergent boundaries, but certainly not the extremely strong ones that you find. All right, when the plates are moving towards each other, of course, this is convergent. The ocean. So remember, the oceanic crust is more dense than the continental crust. So this is in this case that they're assuming that an ocean plate and a continental plate are heading towards each other, and so this is subduction. This is a good example of subduction where the more dense oceanic plate will subduct below, and you're actually losing part of the lithosphere, and this is actually where we find these huge trenches. Again, these are usually in the oceans that you find these things. The most blatant example of that would be the Marianas Trench off the coast of the Philippines in the Pacific Ocean. All right, so you have really deep and very strong earthquakes associated with this kind of thing. They can be strong. Mostly moderate earthquakes. All right, so with the first one, these are relatively weak to moderate earthquakes. moderate to sometimes strong earthquakes. All right, and then all right, so this we'll continue with this one. The ocean convergence. So one the ocean plate will sink below the continental plate because, of course, the continental plate is more dense, and so this is where you get these oceanic trenches. All right. Let's see, anything else about this? If volcanoes emerge, this is actually, yeah, this is also where so if you look at what's going on here, as these two things converge, where they're converging, where in the asthenosphere, right, the upper part of the mantle, you're creating this lava, and the lava rises, because it's very hot, and you can actually create volcanic islands, right? So of course, one good example of that would be the Hawaiian Islands, but there are other ones, like Japan has a whole bunch of islands that are created this way. The Aleutian Islands, the Tongan Islands. There's lots of island chains all over the planet that are created this way, where subduction is taking place, and the magma rises up, and as the continent moves, as this lithosphere moves, you're going to have the magma solidifies, and if enough of it solidifies, it'll break through the surface of the ocean there, and it'll create islands. All right. So anyway, let's see. We're still on ocean continental convergence. The denser oceanic plate subducts. We just said that. As the plate descends, partial melting occurs, generating magma. I just mentioned all this. The mountains produced by volcanic activity from subduction, lithosphere and compression and convergence. Okay, yeah. So, all right. So yeah, we see this, of course, with the Cascade Mountains in North America, and the Andes Mountains in South America. Okay, so this is I guess this one was ocean convergence. I kind of missed that. Sorry about that. So this is ocean convergence when the material will slip below, and so this is two ocean. Maybe this basalt is slightly more dense than this basalt over here, and it will slip below. So that's ocean. And that's the part where you get, you're not quite to the continents yet. Okay, so this one is ocean continent. So right at the, right where the continents begin, the ocean plate slips below, and that's subduction, and that's when you get these the mountain building, right? And that's the thing I was talking about with the andesitic rock, right? So think about it. You have all this material, ocean creatures that have been around for millions and millions of years. They die, they end up at the bottom of the ocean. But as that material subducts, some of that material gets mixed up with the magma, and that forms new rock at the surface, right? That's the andesitic rock, right? Okay. Anyhow, so that's ocean continent conversions. Okay, so sorry. Yeah, and then this one is continent convergence. All right. So three convergences. Okay. So ocean. Right. You still have subduction in each of these. You have some. Well, in these two, you have subduction, and then this one. you have some